Okay, folks, let's get going. So, I think lots of people posted or shared quite a number of top solutions. I'm kind of going to share my notebooks. Can you guys see my screen now?
Yes, we can.
We can.
So I don't know how much time any of you had to look at it. I didn't have too much time this week, but we can just spend some time going through some of the top winners and then look at whether any of them have published code or just the approach, because just the approach doesn't quite completely help us. Sometimes it helps to have, or more often it helps to have the entire code as well. But there's lots of people that posted their approaches. So I have a few of them here. And, also the other thing I was curious about, and I don't know whether either of you, Mayank or Terence, had a chance to look at any methods that use, any simple methods that don't use a lot of ensembles. And personally, I was never able to get on the public leaderboard anything below 0.29, I think, which was what was the notebook that had public data, and I had trained personal models as well, but it didn't, none of those seemed to work out. So anyway, the first place solution is a
I
huge
was on the
ensemble.
same boat. I didn't get below 0.29 on the leaderboard too, while I trained several of personal models with the Chris DOTs and then later with the other notebooks that had various scores.
Yeah, so I had done, the one other thing which I wish I had started earlier than I actually did, but I never completed it because it was kind of too much of a stretch in the last couple of days, was trying to implement stochastic weight averaging on top of some of the models, but I don't know how much that would have gotten me, because at least I just quickly scanned and bookmarked a number of tabs that I'll just take you guys through and we can discuss them. But all of them seem to have quite elaborate approaches that they took on. So I'm kind of still sorting through them, and I intend to kind of at least try and implement one or two of them to kind of get familiar with the techniques that people have used. The first place solution is like a huge ensemble, as they show here. But what is interesting is that they all start just with EEG. So it's almost like at least the first place solution doesn't use the spectrogram data at all, as you can see. And then they each kind of, the raw EEG, I have typically seen a 1D model. I guess I also saw a 2D model, to be fair. I think there was a GRU and those kinds of things, but I don't know what specific 2D model these guys used. And as you can see, there were like 4 members of the team. Each of them came up with their own kind of approach to take directly. This guy just used the direct data or the raw EEG, but then, this guy seems to have done frequency and again this frequency. And of course, we also saw, I think even Chris Biotit's example of a 1D temporal, followed by 2 2Ds, and then fully connected and then a complete ensemble. I don't know what this Entmax is. Have you folks encountered this terminology or this Entmax instead of softmax?
No, I have not.
Yeah, so
I
that
haven't.
would be
Yeah.
something interesting to look at. And as you can see, pretty elaborate approach to this is Muku. So he's the guy who has done this part, 1D, and then 2D, and then two 2D models. So you can think of this itself in a way as an ensemble. So you can see the stuff that he does. And then image of 16 channel or average 4 channel spec. So there seems to be a lot of custom work done here. And then also you can see that, the 2D CNN that he uses is very specialized, like Swin V2 Tiny Windows 16. I haven't even heard of those kind of models. And then there is this anterior posterior montages. And I don't know whether that's just the two sides of the banana diagram or anything more than that. So quite a bit of details. For example, he doesn't use the standard STST. He says it doesn't appear to be a good representation. And instead he used superlets. I haven't heard of this either. And then something called CWT. I don't know what superlets are. I guess, here, in case we're wondering. What's that? So I guess this is a better approach than the ST. Interesting. I'd never heard of this, so something worth, I guess, learning about. And what is CWT? I guess we'll find out when we look at the other one. It says the superlet is better than STFT. Interesting. And then you use the best backbone, Win V2 Tiny Windows 16. And then look at the models. In fact, other than maybe, actually, to be fair, I haven't even looked. I've heard of Inception, but I haven't heard of Inception Next Tiny. So kind of interesting that, have any of you guys heard of any of these models?
No, I haven't seen these before.
Yeah, so it's kind of fascinating because lots of new exposure to new models as well as new conversion of technique rather than using the standard STFT, which everybody was using. Fascinating. Have you seen this, Mike? Any of these? I mean, I've heard of Connext, obviously, but or Inception, but I haven't I'm unaware of any of these, or even, I mean, again, I've heard of Swin V2, but not of this Swin V2 Tiny Windows 16.
I think so. These are the derivatives of the original models. I mean, the
Yeah, but
tiny
I
one.
mean, but you know, other than Connext and Swin V2, and even Swin, one thing I don't know, and Mike or Terence, I don't know whether either of you folks know this. I'd recently bookmarked or seen a paper which talked about using a visual transformer, but said something to the effect of visual transformer without restriction on input size. And I believe I saw somewhere that all visual transformer based models, and it's been a while since I looked at visual transformer models or applied them, but they said that in the paper something to the effect of visual transformers have a input size requirement or limitation. Are you guys aware of what that was referring to, or whether there is some kind of a size restriction or limitation in terms of usage of visual transformer model? Because this paper seemed to claim that it had done away with that limitation. I'll find it. I just haven't. It came out in the last month or two, the paper I'm thinking about. But are you folks familiar with why visual transformer models have the size limitation or restriction?
I'm not. Maybe my young is.
Say that again. I was busy a bit.
Do you know whether you know WIT, right? Visual transformers, and then
Yes,
I thought
yes.
Swin is a version of that or a precursor of that. I don't remember which now. Is Swin a visual transformer model? Do you know?
Swin is related to the transformers. It's like sliding window. So those patches are sliding in the way that they are placed, and the attention is calculated on those windows. So
Right.
if
But then do you know whether Swin and or any other visual transformer based models which use attention have limitation on size or restrictions on the size of image that they can be applied to, or is there any kind of a constraint, limitation, or restriction that you're aware of?
the Swin
Because I saw
V2, yeah, the Swin V2 has scaled resolution with scaled capacity and resolution. So it was applied on that fashion. Let me open up the research paper here to see exactly how much resolution it had, but I think so. Yeah, I've opened up the paper and I think so. The ImageNet top one accuracy had W12, W16, W20, W24. But let me try to search the exact pixel range of how it scaled up.
Yeah, the question is there a limitation on whether you can use the method on, is there a limitation on the size of the input to the methods or anything of that kind, like image size that you can input into it?
In the conclusion, it says 1536 cross 1536 resolution, including the
Okay, but
post-norm
that is,
and scaled, cosine attention.
yeah, but that is just what they've applied to, right, in the paper.
Yeah.
But is there a limitation that you're aware of, or can you apply it, for example, to a 224 by 224 image or a 512 by 512 image? Do you know whether
Yeah,
there is
they
any
have
kind of
fine-tuned it to 224 by 224 or the 512, 518, 384, 640. So the Swine V2 base model, the B, L, and G, they have three models here, B, L, and G, and B is 88 million, L is 197 million, and G is 3 billion. So the 88 million has 3884. The L has also got 384, and the G one, the 3 billion one, has 640. The 640 pixels by 640 pixels.
So are you saying that those models can only be used with those image sizes? Because,
yeah,
for example, let's say Connext or ResNet or those kinds of things, they don't have an image size restrictions. You can use them on a 512 by 512 or a 224 by 224. It doesn't matter. But are you saying
I
that?
see what you're saying. Yeah. I will have to. I think so. Tim has Swine V2 implementation.
Yeah. No, it has it. But I'm just curious whether there is a limitation of a transformer model and its applicability to certain size. That's my question.
Yeah, I think so. We will have to search a bit on.
Yeah.
What
okay, that's fine.
it
Because but anyway,
yeah,
I've seen
on the Hugging Face model card of Swine V2 large, it says image size resolution of 256 cross 256. That's the large model. It has. So
okay, but it seems to then have a restriction on the size then.
Yes.
Yeah, I wonder.
According to this implementation of this, they have a restriction here.
Yeah, I wonder why, and B, as I said, I'll probably post in Slack later once I dig up the paper, but I saw a recent paper go by that I wanted to kind of bookmark and follow up on, which claimed that it had addressed this limitation, not Swin particularly, but in general. Anyway, moving along, I haven't heard of these models, nor of this one. Of course, Pico refers to size, Tiny refers to size, S18 probably refers to, but I haven't heard of CalFormer, GCWidth, or MaxWidth, or PoolFormer for that matter. So interesting that new models are still there, which are quite different from things that we are familiar with. Because none of these are like the traditional what we have seen, a lot of people using, including what I did with ResNet or EfficientNet or any of that kind.
Yeah, MaxWidth is also defined in Tim's library, and the model card says that.
I mean, I'm sure most of these are available on Tim, but I haven't all I'm saying is I haven't seen the most common models are the ones that I've added of DenseNet, EfficientNet, ResNet, things like that. But these are some new ones.
This MaxWidth Pico also has an image size resolution of 256 cross 256. So it's limited to this size. So the images that it gets, I think so, 256 cross 256. I think so. All the models that are listed here have got 256 cross 256 or 364. These are the resolutions that they operate on.
And the other thing which I have not yet, although I used it, but I am not, if somebody were to ask me what's the difference, I don't know it. So that's something else worth looking at, is this Aiden optimizer as compared to the traditional or, commonly used Adam or Adam W. This is the one that the guy had the code for. So the code is available for what Aiden does, but during the competition, I didn't have enough, or I didn't pay enough attention or detail to figure out how Aiden is different from Adam or Adam W. That would be something else. And then, of course, two-stage. So that's an interesting thing that most people figured out, that in this competition, it's important to do this, because in less than a certain number of votes, the confidence level is low when very small number of people are telling you what the classification of the data is. Interestingly, the guy hasn't done any pseudo labeling. But again, interestingly, he implemented label smoothing, which is essentially, at least label smoothing as I recall it, was more that if you had a hard 0 or a hard 1, then you kind of smooth it by saying, my zeros, I'm going to make them all like not 0, but say 0.01 or 0.2. And then if suppose you had 10 classes, and only one class was a 1 and all the others would be 0, which is what will happen when you do a softmax classification, then instead of making it hard like that, which is one class of 1 and all other classes 0, you make all the 0 classes, instead of zeros, you make them 0.01. And because now you have a 0.01 times 9 in your 0 class, that becomes 0.09. And so your one class becomes, I think, if I recall correctly, 0.91, so that the sum remains 1. But I have to look into how just adding an offset of 0.02 to each vote before normalization achieves label smoothing. He does say how it does it by adding this before normalizing. A stronger regularization is applied to the label with low vote counts. And that because they have the low vote counts have low confidence. So that's something else which is kind of a tweak to keep in mind, that I guess this is another way or an easier way of achieving label smoothing, is just adding some offset, to some values and then normalizing. And the offset, I guess the reason it works, and feel free to comment whether my guess is correct or not, but I'm guessing the reason this works as label smoothing is because when the value of your, let's say you have the classes and their probabilities, right? And if the probability is very low and you add a 0.02, that is a larger fraction of its native value. So that makes it a stronger regularization, because you're increasing the value of a very low value significantly. Whereas if the value is already high, then by adding 0.02, you don't do much to it. So you tend to kind of increase or bump up the low confidence, or you bump up the low magnitude values, and then you normalize. But I didn't know that you could do this to achieve label smoothing. Has any of you guys ever, I mean, I have done label smoothing, but not this way.
I think so. If strong regularization would be applied to labels with low vote counts, I think so. They will be in the distribution. They will have uh, a small curve as opposed to uh, yeah, as they say that they have relatively low confidence, and the curve is small there. The top point is small there. So I was wondering whether in whether in applicability of this would this be sufficient, or should we normalize the large values which have uh, a bit of irrational behavior or out of distribution or uh, values that will be uh, will have stronger benefits to stronger will have I think so good benefits in a stronger regularization environment. So I was wondering that.
Yeah, no, the way label smoothing traditionally is applied is to increase the value of, like I said, if you have like 10 classes, then you have 9 classes which are 0 and 1 class which is a 1. What you actually do is, instead of it being 0, you make the 0 classes have values of, let's say, 0.01. And you make the last class, which is the the class that the thing belongs to, which should be 1, you drop it by the amount that you've increased the other classes so that it all still adds up to 1. That's what I've seen traditionally label smoothing applied as. But this just says, just add an offset to every vote before you normalize, which I didn't think that you could do it label smoothing this way. That's why I was curious. But it would be interesting to see whether this is exactly done as it's talked about here, which would mean, I don't know whether the code is provided as well in these guys. But that'll be interesting to check out. And then some augmentations, random time shift, which I have not seen. XY masking, yeah, we saw that, but then it is only for specs. So that means assuming specs stand for spectrograms, and they've only used ETs, I guess they're just doing this, and I haven't seen anybody do that. So very interesting. And somebody commented on that, what I already commented on. And then, different way to handle it. Anyway, here is a couple of new techniques to learn about: sparse max and int max.
Yeah, these function this line below that line that says these functions can output sparser results.
Yeah, and the sparser seems to be the fact that softmax doesn't give you perfect 0 on some targets, but these two do. So using int max has enabled them another 0.04. Those are the two papers, I guess, for Entmax and Sparkmax. Interesting. Here is CWT. I wonder what is CWT. Let's try that. Okay, what is CWT in frequency domain? Oh, the continuous wavelet transform. Interesting. Again, not something that I'm familiar with at all. That's interesting. See, again, these are techniques that at least I haven't seen anybody else use. Very interesting. CWT or this, what was the other thing this guy used? The first guy. Superlets. Interesting. So at least a couple of new things as well as this Entmax, Specmax. Man, lots of fine little detail. And then I can resize and then do that. Interesting. Yeah, see, the technique is fairly traditional. Once you go through the CWT, you get whatever, and then you just kind of smash it all into a 512, then you apply that, and you do something similar on this, stack, this ensemble, and then do that. See, here's the continuous wavelet transform. Interesting approach. Yeah. Very interesting. And then this, all of them seems to do 18 signals. Is that consistent with the banana, double banana thing? I don't know. I'll have to go back and look at it. But it seems to be, right, from what this guy shows. Yeah, otherwise nothing dramatically different that they've done, but yeah, very interesting. Anything else on this one that you want to call attention to? Lots of stuff to learn from this one. at least two new techniques, CWT and the superlet, as well as some of the models, as well as the Entmax, whatever the other one is, the couple of ways of doing the max thing. What else? Oh, the normalization or stuff. All those are fascinating new techniques to have in our pocket in the future. Very interesting. Okay. By the way, just so you guys are aware, I think mine is, but I don't know whether you are, Terence, maybe you are. I think I remember adding somebody, but one of the things that I had done was, let me see where it is here. I have shared, I post the link to it, but I have a shared Google Doc that you can kind of, yeah, here. And if you don't have access to it, let me know. But the purpose of the document was to kind of capture and recollect the ideas. So I thought it was pretty good to capture some learnings as we went through the competition for future reference.
Okay. You said
So
you posted it in the chat area, or
no, I have shared it with people who, if you can DM me on Slack, I think Mike, you have access to this, right?
No, I don't. This is the first time I'm seeing this.
Oh, okay. Because I think, so if you guys can send me your email, I can share. I didn't want to put it on the just blanket share with anybody who has the link. So if you, or actually if you send me your email on Slack, just DM me your emails. I'll add you to the document. That way you can then go in and add. I'll add you as an editor, so you can go in and add any learnings that you'd like to. For example, I intend to add the links and comments about, hey, these techniques were used. This is the benefit, short thing. So that the point is, in the future, as we go through other competitions and stuff, I mean, we forget things, and this can serve as a repository of things that, we can go back and look at. That was the intent.
okay.
So for example, here's somebody who said, Chris had actually posted this of, okay, what's the reason to use group K-fold instead of stratified group K-fold in a competition? And how to determine where to clip data in case of spectrograms. Transforming inputs to be good for neural networks. Then when cropping images for neural network, it's good to be the multiple of 3. Then things like this, which again, can potentially help us in the future. So if you can share.
I've just shared it in the chat. My email
okay.
ID.
Yeah,
You
and
can
I
Okay.
just
copy
sent you
paste
a,
it.
I sent it
Yeah,
directly.
I'll add it. Yeah, you can just send it to me on Slack as well.
Yeah, I think.
Okay. That's that. Now let's look at the second place and see whether there's anything here we can learn from. I don't quite understand what this guy is saying. I might have to take more time to go through it, but bottom line, he seems to be saying that using a 2D model doesn't give good results. So he went to a 3D model, which I have not seen anybody else use. So that's another fascinating approach difference compared to anybody else. So at least it looks like the top two entrants completely kind of followed approaches that at least I didn't see anybody else in the competition approach or use these techniques. So that's good to know. And then, of course, he still ensembled and he stuck to the standard STFT transforms. So 3D CNN for the spectrum and then 2D CNNs for the raw EEG signal. So he talks about, somehow why it produced worse results than a single image. Yeah, I got even for me with efficient at B2, not B5, but with B2, I got to not a leaderboard score of 0.26, but my private leaderboard score was 0.31, I think, or 0.34 actually for a single model. It's kind of interesting. He's able to get a 2D model. So I'd be very interested. I'd be very curious whether there is code with this because I'd really love to see what he did differently. Because I used a 2D model, the best I could do, of course, with efficient at B2. I didn't try B3. I don't, here's where, again, comment about Kaggle these days is even my efficient at B2, I think B2 barely fit or had a little bit of headroom. So I don't know whether my Google A4, A100 computing graphics cards or whatever the NVIDIA would have allowed me to use an efficient at B5 without running out of memory. So that's another kind of limitations we had when we use these.
I tried B3, efficient at B3 on my machine. I had to lower the batch size a bit, but it didn't give me a higher score. Instead, it was lowered around to 0.34, 0.35. So I didn't try further.
Well, how much memory does your, or what are you, how much
I have
GPU memory?
8 gigs of VRAM.
Oh, 8 gig only, not,
yeah.
Because I think 8 gig is fairly low, right? I think A100 gives you close to like 48 gig or something.
Yeah, 40 gigs, yeah.
Yeah. So how much did you drop the batch size to then? Like 2 or 4 or 8 or something?
Yes, 4. The batch size I had to drop to 4. So
yeah, but then see the problem is that it could be your lower scores could also be because of the small batch size.
Yeah, but the B2 was fine, and B3 with
B2 how much did you get with 8? How much you would still have to have like
B3
at most
on B2 I was using 16 as a batch size.
Yeah, and B2 I think the batch size I'm using at A100 is 32.
Yes. So that's the difference.
Yeah.
So I had a pretty constrained environment in which I was trying. So I'm still waiting for Blackwell. I was trying to update it with the previous year's the 4090 series, but I thought I should wait and I have to change my power supply unit 2, the PSU that I have.
But how much is the Blackwell is the latest and greatest, right? Like after the
Yeah.
Hopper one.
Yeah.
So how
yeah,
much does that? I mean, but the data center ones have much more, right? You're talking about on your PC. So how much does that have?
So Blackwell doesn't the consumer cards of Blackwell haven't been released yet. It is yet to release in a quarter or two. So I'm still waiting for that.
Right, but the previous one, like Hopper, how much does that have?
It has 24 gigs. The maximum consumer card, the 4090 has 24 gigs.
Okay, so that is equivalent to the, on the Google Colab thing I get with, what is that called now? I forget. Instead of Ampere, the one beginning with V.
Yeah, the Volta. I think so it's called Volta. Yeah, the V100.
Yeah, the V100 is about 24 gigs. The A100 is 48 gigs. So they charge about 13 units per hour on the A100, whereas the V100 is like about 5 units per hour. But then I can't
V100
run.
is about 16 gigs. If I'm not.
Yeah, no, I
may be
mean
mistaken.
not.
Yeah.
No, no. I think the V100 at least on the Colab platform. That's why I said the data center ones might have more memory. But the V100 provides about 24 gig, if I'm not mistaken, of total memory. And I was talking about the charges. When I said units, I meant like, you get about 150 or 200 units a month for $10 on Colab, $9.99 if you're counting or not the one additional cent. But it gives you about 5 units per hour. That is, you can run V100 and it takes about 5 units of the 200 units that you get in a month. But the A100 takes up about 13 units per hour. So if you run for 4 hours, you've knocked off about 1/4 of your monthly quota. But then you can pay another $9.99 and get another 200 units if you run out of units.
I think so. They have launched T4 too.
They have, I mean, that is the lowest. So it gives even less. But I'm hoping they do better than A100 because, as I said, some of the, I think I'm talking from memory, so I could be wrong, but when I tried with 16 or 32 batch size, when I tried to do B3 or B4, I forget now, I tried one of them and it ran out of memory, but I didn't bother dropping the...
They have a new one, the T4G GPU. If you can go to Colab and open it up, it has 24 gigs of memory. It was recently added.
I see, but I think the T4, if I recall correctly, was
it's L4 or T4. I'm not too sure, but
yeah, I'll check it out. But anyway, you're off on a tangent. So in this case, he does combine the two, the 3D model with the 2D model, which is kind of interesting.
The prices for Colab Pro has also increased. I think so. It's $11.79 per month now. Before it was $9.9.
Yeah, even now I'm getting 9. I don't know whether I signed up early and I'm still on that plan. Okay, so this one doesn't seem to have too many things other than the great idea of using 3D CNN. And why that helps. So that's interesting. Okay, let's move on. third place. Again, an ensemble. Pre-trained 2D to the MEL spectrogram, and then 1D before using squeeze former blocks. Is squeeze former anything different than squeeze and excite? Let's see. This is interesting. I mean, the generic approach saying that this is the way that the original data on the competition was generated. These guys have back engineered, reverse engineered it, and then used that to filter the data in order to kind of get high quality data of only this many rows versus the 106,000 rows. That's an interesting approach. Fascinating. And then otherwise, it's just a combination of 1D and 2D models without pseudo labeling or anything. And they didn't use the 10-minute spectrogram either. And excuse me. The other interesting thing is this observation, which is very different from what everybody has done. Because everybody else using STFT normalized. So that's something which is different too. Then heavy augmentation. And then I've seen this in a couple of different cases that, you know, because the classification is actually done on the middle 10 seconds, that actually adding an additional image where you zoom in to the center 10 actually help people achieve better results. So that's something else that I've seen multiple people refer to. So, you know, instead of taking the full 50 seconds, 0 to 50 from an EEG, just focus on the middle 10. So that's something interesting too. So this 18 that I was rattling off before continues, I guess, to be the correct figure, correct number, because you can see that, you know, these four, the middle three, these five on the closest here, and then this is 5 too. Yeah, I guess so. So there are 10 on each, and then 3. Then where does the 18 go? Okay, 8 on each side because it's the deltas, and then the delta of the middle guys, and then Okay, 8 on this side. So that's why it's 18. Okay, got it. Okay, so then what is this squeeze former? Very custom implementation. Interesting how they carefully architected this. That's very interesting. Wow, lots of detailed write-up. Yeah, see these guys, you can see that on the public leaderboard itself, they got 0.25, 0.24, 0.22. Pretty amazing. Best, look at the best single 2D model. 4 folds, 2 seeds per fold. So that means 8 models per se, total ensemble. And on the public, they got 0.24. That's amazing. As I said, we went with ensembling 10 to 20 models. We were not able to hit anything less than 0.29 with 2D. And they got 0.25 with a single 1D model. Interesting. That's at least each of the 3 top winners seem to have some unique learning that we can take away from. So at the time, I think next week I'll write up not all of the details of this because that I'll just link to the reference, but kind of the takeaway of what key things that I think they did differently. I mean, lots of details, but I'm more interested in the big picture. Yeah, like, I don't know that, of course, it'd be interesting and learn about all these details, but I'm just saying, you know, things that we are completely unaware of. Let's see. This is 4th place. I'm going to, in the interest of time, since it's already 11, I'm just going to jump to Chris's solution. 6, 7, I think this is his. I'm not mistaken. No, that's the 10th. This would be 8. So this is Chris, whose early work really helped all of us. And again, as with anything else, you know, he's kind of applied, let's kind of count the experts and only take their opinion, which is again a different way instead of going through the 2 stages, stage 1 of low confidence and stage 2 of high confidence. He's just saying, you know, let me just take not the overall opinion, but the expert opinion, and he kind of defines the expert opinions as those where the votes are more than 10. But the one comment I would have in general, you can see this in the third place winning entry and even in the 8th place entry. Probably you could argue that even the first place winner's approach of using CWT or the other one, Superlets, is kind of along the same vector, which is the thing that increasingly I'm noticing. Maybe it's always been true, it's just that more heightened for me is the quality of the data that you use seems to be, if you can somehow do a lot of work to improve the data that you're inputting into the models and processing, then that seems to give you a much, much better results. What do you guys think of that generic observation? Any thoughts, comments?
No, not for me so much. I'm really trying to play catch up. I missed the entire competition this time around. How about you, Mayan? Anything?
Yeah, those generic models help in some sense, but even Chris had to double down on the specifics here. So he trained 3 separate models, and the training sizes, the were different. The as we see, the 3 models are totally different in their ways and the base models that they used. So it's a kind of specialization into this this problem set that those ensembles represent. And
yeah, no, that is true. But I was just saying that, it seems to me that of course you have to do a lot more. I don't mean to take away from all the customization and the engineering work that a lot of the winners have done. But I'm just saying the one general thread I see running through multiple efforts is this effort to clean up the data, to kind of use high quality data, if you will. And the quality of the effort you spend into improving the quality of the data seems to yield quite high reward. That's my comment.
yeah,
All other things being equal, it seems any effort you put into cleaning up the data is really rewarded well, because you can see even in the third competition, they kind of reverse engineered what had been done to generate the data we have and then cleaned it up to just use 6350. The first guys, for example, used highly effective frequency time domain translation to input high quality data into the small models that they were using. I mean, I'm not saying they were still ensembling so many models, still techniques like, Entmax. So I'm not taking away from any of that. But all of the things being equal, it seems the effort you could spend to really clean up and utilize high quality data or the data with high confidence, like even as a baseline as he has done, that seems to be contributing quite a bit to getting much better results, is my commentary. I mean, you have to do a lot more than just that, but I'm saying that seems to be a generic underlying thing to pay attention to. So here's his summary. And again, he's used, interestingly, all weight models. See, and this is what I mean, Mayank, that this is exactly, if somebody were to ask me to explain this, I wouldn't be able to. but this convinces me that what I was rambling about a little earlier is probably accurate, which is see the same model, right? Tiny with 21M, which might probably mean it's a 21 million parameter model. But you can see that you probably need two separate models, a tiny with 21M 512 and a tiny with 21M 224, to depending on the size of the model input images that you're giving to it. And I don't know whether either of you know why that is the case, but it seems to me that there is a limitation that, unlike in case of ResNet or EfficientNet or something, for example, Efficient MP2, you can use a 224 by 224 or you can use a 512 by 512. But in this case, your model seems to have to change if the size of your input changes. You see that? And that's, I think, unique to width-based or transformer-based models. I don't yet understand why, or I can't recollect why. That's the comment I was making earlier too. Okay, let's keep going. ED1D, and then he used pseudo labels for less than 10. Oh, so he uses these models to label the less than 10 word 10, and then uses those labels to train or as additional data feeding back into the same three models. Interesting. Yeah, three trained models, remove the three heads, combine them into one model, concatenate the final embeddings that you get, add one new head. Then we train with 2 times copies of this data concatenated with 1x copy of what with pseudo data. My God. Note the 2D server actually 10 to 10 sec. And yeah, again, the 10 sec spectrograms. This is another instance of what I refer to as high quality data or improving the quality of the data, right? In a broad sense, because you're not just paying attention to the entire 50, but you're also zooming into the 10 seconds, which is the basis on which the labeling has been done. So very interesting that. And all this gives him a leaderboard score of that. Wow. Public leaderboard. But the interesting thing in this case is he doesn't use, I wonder if he used this approach and utilized the CWT or torch, superlets, how much more better his results would be. But anyway. So that is the 8th one. There are obviously, I skipped from 3rd to the 8th. There's a 4th one, 5th one, 6th, 7th, to the 8th. It's the Earth is, and then in the interest of time, let me skip to, there are even like 60th single multimodal attention model. this one doesn't seem to have too much of a description, though. Actually, has a lot of diagrams. I'll take that back. But I was just wondering, bronze public leaderboard of 0.28, because this is just below where I got stuck. So I was kind of curious what the guy did. And it's a TensorFlow thing, which kind of, and then he uses just an efficient net model. Yeah, this one seems to be fairly standard. I don't know whether he had the whole input, I guess. And he uses an efficient MP0, but does he say that it's a single or anything? No, he doesn't say anything. Oh, he combines multitude of these. Makes it a 512 by 512. Yeah, I was just curious how he got to 0.28 versus my 0.29. So that's something else I guess I'll look into in greater detail. I don't know whether folks are interested in details, but as to how he was able to get to 0.28 on the public leaderboard. So as I said, I couldn't get below 0.29. And also, is this ensemble of multiple? Yeah, 5-fold. So I guess it'll be just this. Oh, it's an inference. Okay. So several more examples. The 33rd, with the 2D pipeline. Don't know what this Q transforms is, something else. So this is another interesting one. There's some new learning maybe potentially for us. Okay, any other questions? I would encourage you, if any of you have any other, I'll add the two of you to that document editor list. And if you want to write up anything in particular, generic things, feel free to do that. As I said, over the next week or so, I'll probably add my takeaways or anything generically that I think are worthwhile techniques to know about from this competition.
You planning to do that for each competition that we do going forward as well?
Yeah, that's the intent. So at least,
Okay.
we could potentially have like a set of docs that we
Mhm.
can go back and refer to
That's awesome.
for classes of problems that we encounter. Of course, over time, techniques and tools people use will change, but nevertheless, at least some baseline of techniques, tools, tips, generic things that we can learn and take away. Because one thing I found is, for example, in this competition, this STFT approach itself, we had used that for the bird noise competition that Steve and I had participated in. But, by the time we get to this competition, it's been about 18 months to 2 years. And I have had bookmarks added, blah, blah, blah. But it was kind of hard to dig up and retrieve important things. So in discussing with Raquel, he was feeling like he started it actually. And then I just said, hey, this sounds like a good idea to do.
Okay, that's awesome.
He wanted to do it on Slack. My problem with Slack is it disappears after a while. So I said, okay, I'll just open up a Google Doc and provide access to people who are interested.
Mhm.
So yeah, going forward, I hope to be able to kind of throw in stuff, or if others are contributing it, at least it's more of my own interest. But
Well, I'm sure that's representative of all of us as well.
yeah, so
Yeah,
can
awesome.
serve as a reference in the future.
Well, that's
I
awesome.
mean, by no means exhaustive or extraordinary detailed, but something that you can quickly look at and say, okay, yeah, I think that it gives me some good new ideas to try.
Yeah.
Or, oh, that's what we did, and here's the pointer to it, so let me go look into it.
Well, thank you.
Sounds good. Okay, I think few people may be interested in this discussion and stuff, so I might post a kind of comment on Slack recording. I haven't been posting that because I think not too many people who aren't attending are interested in listening to the recording, but this one might be of general interest to multiple people since we've kind of discussed some of the top approaches in commentary on it and stuff. So I'll definitely post this recording. Anything else, Mayank?
No, not from my end. I think so. I will review the other solutions too to get a lay of the land of what they did to go
Yeah,
such
if you
higher
find
up.
anything interesting from those, like, higher up or from beyond, like the 7th or whatever, beyond Chris's one, if you find anything interesting, unique, feel free to kind of summarize that in the doc.
Mm-hmm. I don't think so. Those the top 10 have posted. Many people have posted the code along with that, the solutions. So I was curious if.
Yeah, that's something that I'm kind of interested in seeing also, whether anybody releases the code. That would make it more interesting as well. So if you find that, we can maybe take the first half an hour or 15, 20 minutes or whatever it takes next week to discuss it. And then next week we can begin to look at what new competition we want to kind of wade into.
Mm-hmm.
Yeah, I saw a new math one that's, I think the payout is $1 million. That's funny.
Mm,
I,
interesting.
yeah, It just popped into my email. I haven't looked at
Yeah, I
it.
think I've seen, of course, this is all new. Let's see. What is, I think, let's see whether any.
Yeah, it's
So
that
this is the
first
one you're
one.
talking about.
Yeah, I just
Yeah,
saw it
it's
pop up.
about a couple of months to go, so that will be interesting. Yes, I don't know if it mainly. Maybe we can discuss more in detail next week, but this one is, unfortunately only 3 days, so that's not very. Okay, but is there a way to rank these guys about how much time left? Yeah, this one has 2 months. This we have done something similar, but 3 months left, which is good. This is interesting too. 3 months left. This image matching has 2 months. So 2 to 3 months is kind of a good time frame to join because you have enough plant rates is also 2 months. So you have enough time to kind of get familiar with the data, make some attempts, learn from people, and kind of go through a good healthy cycle. So generally don't like to jump into anything with less than a month. Yes, it goes by too quickly, but anyway, we can spend time next week looking at each of these and potentially just thinking which one we want to go into. Okay.
Awesome.
Anything else?
Not for me. Thank you.
Nothing. See you all next week.
All right. Take care. Bye.
Bye.
Bye.